can do. Although I don't have the function, I'm able to find an expression for its derivative. It's a huge leap forward. Okay, so let's choose a problem. That's all we need to do. Let's choose a problem. This is differentiate implicitly to find dy over dx, or differentiate implicitly to find dy over dx and then find the slope of the curve at the given point. So if I have the point 2, 4, I will say when x is and when y is, I plug them in and I get a number. That's all there is to it. So let's choose. So please choose. If not, I will. Okay, I will choose 17. In 17, we are given 2x cubed plus 4y squared equals negative 12, and the point is negative 2, negative 1. Okay, perfect. So they want us to find dy over dx. Find dy over dx, and then evaluate it when x is negative 2 and when y is negative 1. I have to differentiate implicitly. Now let's see what we get. Can anyone differentiate 2x cubed for us?
6x squared.
Very good. Can anyone differentiate? And don't forget. Can anyone help us differentiate 4y squared knowing that y is a function? Oh.
Is it 8y?
Yes, times the inner function prime.
dy over dx.
That's it. And when I differentiate the constant, what do I get?
0.
Exactly. Awesome. So then, from here, I will solve for dy over dx, moving this term to the other side. And divide both sides by 8y. Done. All I need to do is plug in negative 2 and negative 1. Negative. I can simplify, but I'll simplify at the end. Negative 2 squared. How much is negative 2 squared? Negative 2 squared.
4.
Excellent. Over. 8 times negative 1. 8 times negative 1 is negative 8. I have two negatives. I'll simplify. I'll simplify by 4. And 6 divided by 2 is 3. So we determine the derivative of a function that we don't have. We determine the expression of the derivative. And by plugging in the values of the coordinates of that point, we are determining the slope of the tangent line to the graph of y at that point. And this is it. 3 is the equation of the tangent line. In other words, if this is the function, which I don't have, at this point, the slope of the tangent line is 3. Which point? Negative 2, negative 1. Great job. Any questions? Okay, let's choose one more. And then we'll finish up with another section. That's all you will be asked from this section. Nothing else. Anyone would like to choose anything else? Any preference? Anyone would like to choose another problem? Anyone?
No preference.
No preference. Okay, then I will choose. Good. So I would like to choose one with a product. Something like either 23 or 25. No preference again? Okay, I will choose 23 then. In 23, we have x to the fourth minus x squared y cubed equals 12, and the point is given to us as -2, 1. Awesome. Can I solve this for y cubed? I could, but it's easier not to. So we will differentiate implicitly. We will put a dot to refresh our memory or remind us that that is not a variable. It has to be treated as a function. So let's start. X to the fourth prime.
4x cubed.
Excellent. Minus. Careful now. Differentiate the first function.
2x.
Excellent. Times the second one. Plus. Keep the first one. Times. I need to differentiate a function to the third power. What do I write?
dy cubed over dx cubed.
First, we bring the power down.
Oh,
We multiply by y to the second power. And only now we multiply by the inner function prime. Should I do this part again?
Yes.
yeah, could you?
Yes, of course. So remember the function to nth power is n f to n minus 1, the function to n minus 1, times the inner function prime. So we have 3 here. So then I have to write 3 times the function to 3 minus 1 times the inner function prime. Is that okay?
Yes, thank you.
Thank you. Now we got to the equal symbol. And now I have to differentiate the right-hand side. I cannot differentiate the left and forget about the right.
0.
Exactly. Now, careful, I put the minus outside and put parentheses because we may forget to distribute to both terms, and that will be wrong. So now I'm going to write it one more time as 4x cubed minus 2xy cubed minus 3x squared y squared dy over dx equals 0. I distributed -1 to the first term. I distributed -1 to the second term and rearranged it correctly. And now I know I have to solve for this. No worries. This goes to the other side, this goes to the other side, or even better, because it's one term, I move this to the other side. So I will keep 4x cubed minus 2xy cubed. So that's my page 6. So 4x cubed minus 2xy cubed equals this to the other side, changing its sign, of course, don't forget that. And now I have dy over dx. So I have to solve for this. How do I write the final answer? And this is algebra. This part is algebra. So how do I write this? Anyone will give us dy over dx, final form? And then I will plug in that point, x equals -2 and y equals 1. But I have to write the formula first before I plug in.
4x.
This whole thing, excellent.
Over that, yeah.
Yes, 4x to the third minus 2xy cubed divided by what multiplies the variable that we are looking for. Awesome. That's all I needed. Now I plug in what I need. -2 cubed is -8. 4 times negative 8, negative 32. Negative 2 times negative 2 is 4. And 4 times 1 is 4. 3. X squared is 4. Do not simplify. Careful, careful, careful. So negative 32 plus 4 is negative 28. 3 times 4 is 12. And I will simplify by 4. And I get negative 7/3. And this is it. Any questions? Any questions? Anyone? Any questions? The last thing that I wanted to say from this chapter, the very last thing, is section 3.9, related. I don't like the name, and I'll explain in a minute. Related rates. I'll explain what it means. See, here is an example. Let's suppose we have a balloon and it has no air in it. And I start pumping air in it. And more. And more. And so on and so forth. Continue. Assuming that the balloon eventually becomes a sphere. So I have a small sphere at first, a bigger sphere, and a bigger sphere. What really happens here? The radius R1, R2, R3. So when I pump air in the balloon, let's say initially it had 1 inch, now it has 5, now it has 15 or whatever, I don't know, 16, 17, whatever you want to say. So because R, the radius, changes, it basically becomes a function of time. Now it has 1 inch. I pump and I continue pumping, and it becomes later on 5, and continue pumping air in the balloon, and then eventually gets to. So the radius is a function of time. In other words, the rate will be dr over dt. What else happens here? Volume. V. It has a small volume and then bigger volume and bigger volume. And volume V is a function of time t, of t too. Because it changes in time. What will be the rate of change? It will be dV over dt. And the surface area and the circumference and yada yada, and I can continue with others. So what is all this? Well, the rate of change of radius and the rate of change of the volume are related. So the title should be clearer, I think. Related rates of change. But they just said related rates. So why would dr over dt and dv over dt be related? Very simple. Because they are related anyway, before they become functions. So the volume of a sphere is 4 pi over 3 r to the third. Volume, radius. I'm going to put a dot underneath because they are both functions of time. And now when I differentiate, as we just did implicitly, this becomes dv over dt. This, bring down 3, because it's a function, multiply by r squared times dr over dt. Yes, I'll simplify. Here's the point I'm making. These two functions are related or are in the same equation. So there is a relationship between them. also their rates of change are related by this equation. So when this changes, this changes. So that's what related rates mean. Something happens at the same time. So there is a relationship there is an initial relationship, and also a relationship exists between the derivatives, between their rates of change. It looks complicated. Let me show you. Let me share my screen. And I want to go to page 364.